Hello.
फोटो डालो.
Good afternoon, everyone. Thank you very much, the Vjit management, for giving us an opportunity to explain the latest developments, what is happening in particularly the remote sensing area. I think you have been listening to the NRC experts on satellite remote sensing for past few days, and then you had some exposure on the dual applications. And today morning I think we had on the Aicte, and tomorrow I think on the mobile application. And we will also be visiting the Tsunami early warning system project tomorrow. That's what I heard from the HOD. Okay, so we have a contribution as part of the Inquest early warning system. Tomorrow you can see how this data is in action. Tomorrow, when you go there, when India actually had this tsunami in December 2004, I think most of the people would not have born, I think, right? Yes? Born? Maybe 1 year old? 2004 December, so it is 20 years now. If you are in 3rd year or 4th year, maybe you will be 1 year old, I feel. Okay, so at that time, settled? Okay, so it happened in 2004 and it was a huge damage on the east coast of India. Millions of lives have been lost. Actually, the tsunami started somewhere in Indonesia at around 7 o'clock. When it reached the Indian coast, it was around 9 o'clock. Fine. Now, at that time, we thought that India is not prone for tsunami, whereas Japan is known for the tsunami term. Tsunami means harbor waves. So it's a Japanese word. Even when I was doing remote sensing at that time, we just know that it is an harbor wave. Never we knew the damage of a tsunami in the real life. So subsequently, after 2004, India, I think, can take this out. So now, now the tsunami early warning system is in place. Tomorrow you will come to know. Now any actually tsunami gets developed when there is an earthquake in the ocean floor. Which not all earthquakes will under the ocean floor is going to generate that type of tsunami, but always there is a probability. Now, with the tsunami early warning system in place at Indian National Center for Ocean Information Services in KOIS, which is there at Pragati Nagar in Kukatpalli. So we have the capability to give an alert within 11 minutes. Okay, so what happened? Had it been there in place, we could have avoided that tragedy. Okay, we lost millions of lives in that, and subsequently India began that exercise, and then from aerial services, just as part of this, because it is terrain modeling, how the terrain modeling is used in disaster management, and especially in tsunami early warning also, how this terrain information is useful, I will try to cover. Okay, the basic rule is whoever speaks will get the question. Okay, if you don't ask me the question, we will get the question. Fine. let it be interactive because I can understand it is after lunch time, this is normal. That is specifically after lunch, it is slightly difficult, but I try to make it as interesting as possible. At some point in time, if you say, sir, okay, one of the basic things what I want youngsters is, see, a lot of people will be talking about, I think, all the recent time, the buzzword in the industry, computer science industry is what? AI, ML, DL, CNN, ANN, generative AI, these are the terms. Ultimately, what you people have to do is, because even my daughter is doing her final year computer science, so what I should be useful. Maybe at this age you will not know. Maybe in the long term, maybe at my age, when you are going to give a lecture at some universities in India or US or UK or in Europe or in Australia, you should raise to the level so that your work should be useful in the domain. Fine, that should be the basic objective. As I present this case, just allow your mind brainstorm so that maybe as a group or something, I don't know whether you are in final year, second year, third year, if you want to do a small project, if you are getting fascinated about it, you can form a small group, brainstorm, discuss with your teacher, and then come up with solution. And even if there is an incremental progress, at least if you have a thought process now, it will be useful for the society. Fine, that should be the objective. It's not that VGIT has arranged something, they made you to sit here, they have called me, and it's not so. At the end of the day, when you are listening, and maybe at some point of time, you should tell there were 5 people who came from NRC at that time. That talk motivated me to do something. Okay, that should be the objective of this course. Okay, in case if you have any doubt, whatever it is, you can ask me. I'll just try to clarify. If I don't know, I'll come back to you. Fine. Okay, so basically when we started the remote sensing, you have seen satellite remote sensing on the first day. What is remote sensing? What is remote sensing? So you are observing me without being in touch with an object. If you can measure, it is remote sensing. So what is the orbital altitude of a remote sensing satellite generally? At what altitude the remote sensing satellite orbits? Yes? Have you heard about the first day sun synchronous orbit, polar orbit? Yes? Yes? No? No? Okay, fine. Then, okay, I'll start like this. You people are using GPS systems, right? For anything this generation navigates through. Even I today when I came to VGIT navigated through a GPS based system only. Okay. What is GPS? What it does? Okay. It is a satellite based location service. Correct? What altitude operates? Don't know. Somebody close? 32. No, it is 20,200 kilometers above the Earth's surface. Okay, you might have seen weather reports, right? Cyclone will have a landfall here. Today it is going to be cloudy. It is going to be heavy rainfall here. All this you get a weather report. You get from the satellite. At what altitude normally the meteorological satellites orbit? No, lower orbit is remote sensing satellites. So, see, there are 3 orbits. Okay, you might have studied in your. Just I want to bring a context to you because see, just having a brute force remembering something is not going to help. If you can connect to something, you can understand. Okay, so whether it is communication satellite, see, satellite communication or the meteorological satellites operate at a geostationary orbit. I think you might have studied in your physics class, geostationary orbit will always be, if you have positioned the satellite at 36,000, it will always be above you. Okay, whereas the GPS satellite orbits at 20,000 kilometers, it has an orbital period of around 12 hours. Whereas the remote sensing satellite orbits at an altitude of around 600 to 800 kilometers. So the orbital period is roughly around 100 to 105 minutes. Okay, understood? So at 800 kilometer, if you calculate the orbital, I think you would have studied about the gravitation, and then you would have studied about the orbital velocity. E is equal to something, fine. So the orbital period of a remote sensing satellite is 100 minutes, and it orbits at an altitude of around 600 to 800. Fine. Now I am going to talk about a platform slightly bring you down very close to the earth, where we are going to see how this terrain. Even though I'll be talking about satellite in between, my focus is going to be on bringing you from 600-800 kilometers, bring down to 2-3 kilometers above the earth using an aircraft. Okay, and still bring you down up to 100-120 meters using a drone platform. How you can derive the terrain information. Further bring you down to the ground, and then how to collect the terrain information. So this concept is called as the multi-concept, which I will be discussing in the further slides. Okay, fine. So basically, I am from so maybe I'll start. Which is the one?
Just show once.
No, next slide. Laptop. Pointer होगा. Okay. Before I proceed further, getting into my topic, why I am here to present on this subject. Okay. See, I am from aerial remote sensing facility of National Remote Sensing Center of Indian Space Research Organization. This is the only aerial remote sensing facility as far as ISRO is concerned, and we have two B200 aircrafts which carries state-of-the-art sensors, and whereas once you launch a satellite, it will be continuously orbiting the Earth till its lifetime. Whereas what we all do is, whenever there is a given task, we mobilize the aircraft to a given task, fly that area, and then bring it and then process the data and derive an output. Fine. That is what is our role is. So we have two aircraft. We have the state-of-the-art facility at our place. We have under the same roof the platform, sensor, processing, and data product generation under one umbrella. Okay. Normally, what happens in the case of satellite? I think you might have seen where you were introduced about the Earth station, where the data is received. Was covered in the first lecture to engineering. How data reception happens at the station. Okay. See, basically in the case of remote sensing satellite, we do have a Earth station at Shadnagar. From Hyderabad is around 70 kilometers. I don't know how far it is from here to Shadnagar. So we have an Earth station. Normally the equator, the crossing time of a remote sensing satellite is at 10:30. So you receive the data at the ground station. Subsequently, they do the pre-processing, and then we generate some product. And if the user wants the data, the user takes the data and generates the useful product for his requirement. This is what happens. In our case, we also do that, but most of the projects we have end-to-end processing chain. Acquire the data, process the data, generate the product, and then give the data for some applications. So that is one. Continuing with that, this aircraft can operate till up to an altitude of 35,000 feet, which roughly comes out to say 11 plus kilometers it can operate. And then we have sensors also. It's basically whatever cameras, whatever we have. These are all small format cameras. Whereas on the onboard aircraft, we use a large format digital camera. I'll just show this. All this I'll be covering as part of my lecture. We have the state-of-the-art sensors. In case of airborne lidar sensor and the digital camera, we have mobile lidars, and then recently we have injected unmanned aerial vehicles also for a very small area applications where see aircraft can with the aircraft we minimally for minimum area requirement is around 100 square kilometer or so, and if you have an area which is around say 5 to 10 square kilometers and you want to monitor continuously, suppose if you want to monitor the health of a crop in a given area, volume estimation and other things, Finally, we'll be generating products such as digital elevation models, ortho images, large-scale geodatabase. You may not understand this, but by maybe at the end of this lecture, you should be able to tell me whether you have understood them, if you have understood ortho image, if you have understood GIS databases and maps. If you have understood that means my purpose of coming all the way from my place to deliver a lecture is fulfilled. Fine. And then on top of that, where you can contribute in this journey based on your expertise in different fields, how this can be used for different applications. That is the objective. Fine. My introduction is fine.
Sir, depending on this trilateral conditions,
Which condition?
generally say trilateral condition in order to map the data from the sensors. So, do the sensors will vary according to latitudes? If installation is used?
Yes. Actually, if you see in this case, maybe you can see in the case of remote sensing satellites, normally the requirement, the telescope, the focal length, the type of lenses what you use, the configuration, everything changes. And even if you see in our case, mostly it is like a frame camera, but normally in case of satellite they use a push broom. It all varies because it depends on the what you call as the spatial different resolution. I think resolutions were covered in the first bit. Spatial resolution, temporal resolution, radiometric resolution, right? So spectral resolution. So depending on those things, the sensor characteristics and design changes.
How to integrate data from the different sources? Because integration is a bit challenging.
Yeah, that's why you are any EC student here. EC, you are EC. Okay, well, nice. Okay. Now I will ask you, even your mobile camera is a sensor. Okay. Now, can you fit it in vehicle and then can I configure in such a fashion? Now, you I think some of these cars, I don't know, maybe your parents may be having. You get the 360-degree view. Okay. So, can you design using your some low-cost cameras? I think each house will have 2 minimum conduct mobile phones. Yes. Did anyone experiment taking that camera? Because I still remember in NASA or somewhere, a person has designed a large format digital camera using the mobile camera and integrated it. So, madam, you can think of by coming up with some solution. Maybe as part of this lecture, I will show you some demos also how we came up with the 360-degree camera, which was, I think you might have seen, I think whatever we tell now we have, but whenever we tell related to Google only you will understand. Okay, Google Street View, how many of you have seen? Raise your hands. Google Street View? No? Others? Didn't see? Okay, Google Street View or see. Can you have a low-cost system which can be used to acquire such type of things? And even on a, I think the VC department or you don't have mobile development in this UAV development, something is happening in this? No. Maybe you can think of, because I am seeing the students or the real
mobile developing application, they have Flutter and Django. Django they have web policy. Flutter you
madam is asking like to come up with sensor integration. Interface development and all that is going to be the thing. Suppose if you don't have that capability, maybe somewhere you have to tie up with maybe analysis is also one option for you, or you can tie up with any other ECL or the defense labs like a DRDO and allied labs, and then think of interface. Anyway, you can have some collaborative projects and then you can develop something. That should not be true. Okay. Yes. Next. Coming to the sensors, we have what are the different sensors we have is one is the large format. This is airborne lidar also I'll try to cover in detail. The mobile lidar also I'll just try to give the glimpse of it. And we have GNSS, or GNSS is nothing but I'll tell you GNSS. Do you know any other GPS based systems available in the world? Yes. What are they? Navi, good, nice. Yeah, because Bidu, nice. Lonas, nice. One round of applause. Nice, nice. You are faculty student.
Research scholar.
Research scholar. Nice, nice of you. Okay, nice. And Lonas you told, Guido you told, Galileo you told, Euro, and Navi Kyoto. Fine. Okay, we will show you how this technology, GNSS technology, normally we use it for navigation, but how this is being used in generating precise product, I'll show you as part of this demonstration in this lecture. And finally, we have a GPS being used for trajectory estimation and ground control points. I don't know whether ground control points were introduced as part of the earlier lectures. Yes, no? No, fine. See, finally, the last one is what we have developed at our place. It is basically this one for generating TQ type of thing. It is called as the ISRO-Garden hyperlapse imaging system, which is used to generate both still and video 360 degree. I'll try to show you some of this one, and students can come up with innovative thing. And if you see Google, yes, done systematically, but for as far as ISRO, we have done 5 to 6 sites only. So why you go to Google rather than Bhuvan is, I think you might have seen what are the advantages of Bhuvan in the earlier class. What Google doesn't have, what Bhuvan has got, you might have come to know. Maybe what Google has got, those things also, if you make it more in Bhuvan, the number of hits on the sites is going to increase drastically. Okay, you can navigate based on Bhuvan maps, but whereas we are navigating using Google Maps, I think that shift has to happen. And instead of GPS, why can't we go for a Navic based system? It's not that since I am from ISRO, I am pushing it for the Indian constellation. You should be patriotic, correct? Correct. You should be patriotic at some point of time. It's where the GPS is an American system, you can use it, but at some point of time, it is instead of being in a rented house, better to buy a own house and stay. So that is also a critical thing in pushing for the Make in India and the local technology. Fine. Next slide. Okay. In the case of terrain modeling or digital terrain model generation, there are 4 basic steps, which is going to be the data acquisition. It can be from different platforms. It can be from satellite, aerial, drones, or ground-based measurements. And then you take to a set of processing process which involves different technologies. See, sometime back, if you ask, I think I was discussing with the principal. Sometime back, there is remote sensing, and most of the colleges, if you see the old colleges, it will be part of civil engineering. Okay. Now, whereas, yeah, it can be part of civil engineering, but the remote sensing or the GIS application, you see, now most of the technologies have become what? Interdisciplinary. No more a single technology is going to drive a given application. So if you see in the case of remote sensing, photogrammetry also, sometime back we were working on manual methods. Now image processing, computer vision technologies, Cse-Aiml is being used for generating information product. So it's no more domain specific. Sometime back people thought that it is more related to geographic information system, means it is related to geography. Or cartography means map making. It is no more fixed to a given specialization. It has become interdisciplinary in nature. So that's why anybody can work in any of the technology. Because it's like if you see remote sensing, right from satellite and then development of satellite, and then you have to downlink the data to the ground. So electronic and communication engineering comes, then you have the ground antenna available over there. Then subsequently the processing chain takes over. For the processing chain, there are different things that are happening. Algorithm development, the format, so many things are there. And then subsequently you take it for different applications. If you see remote sensing application, you name it, you have it. Urban planning, you have an application. Soils, you have. Agriculture, you have. Forestry, you have. So name water. So it is no more a domain of a particular subject. So it is interdisciplinary, and all have to come together to develop solutions. Right? And then third one is how this data, see again for computer science, how the data is to be stored in a database. When it comes to the geospatial data, it normally a database we normally don't worry about the location information. You are more interested in organizing the data. When it comes to the GIS databases, how to link the geospatial information along with the database. Correct? The spatial and the attribute information which we know you computer science people normally develop as part of the database. And in addition to that, we have computer graphics, visualization. How many of you heard about digital twin here? Okay. Have you ever seen a geospatial digital twin? No?
Geospatial we have now, but I tried for this process implementation.
Okay. Okay. So maybe some of you, maybe at the end of the day or maybe now, you can go back and see one of the sites called as Cse-Aiml. Cesium. Okay, Cesium, and then see how this tool can be used to see. Now they are bringing the entire city like digital, and then they are trying to link all this. Suppose I think he is showing somewhere, I think in Melbourne, where he has put some IoT based sensors. IoT is what? Okay, IoT sensors have become common, and the smart city development, I think IoT sensors are has become order of the day. So IoT sensors are linked into the geospatial digital twin, and they are able to find what is the availability of parking at a given location.